Hello everyone. After reaction of metals with acids, today we will continue with how do metals react with the salt solution of other metals. We will also learn about the reactivity series and how do metals and non-metals react. So first thing, how do metals react with salt solution of other metals? This you have studied in lesson number 1 also, that is displacement reaction. A metal which is placed higher in the activity series can displace the metal which occupies a lower position from the aqueous solution of its salt. Okay, this is known as displacement reaction. The general equation is metal A plus solution of metal B. The product will be solution of A and metal B. Means metal A is more reactive here. Therefore, it can displace metal B from its salt solution. Let us see some examples. For examples, you have copper sulfate solution and you put an iron nail in it. After some time, what will happen? The color of copper sulfate will change and iron will get a coating on it. The reaction will be iron plus copper sulfate will turn iron sulfate plus copper. Here, because iron is more reactive than copper, therefore it is displacing copper from its salt solution. Some more reactions. What will happen if you put zinc plate in copper sulfate solution? Again, the blue color will turn colorless. Why? Because zinc is more reactive than copper. Therefore, it will displace copper from its salt solution and it will become zinc sulfate and copper will be formed. Then you should always remember this thing that magnesium, zinc, iron can displace copper from copper sulfate solution. But copper is not able to displace these metals from their salt solution. The reason must be very clear to you by now because of the reactivity series, because copper is lying below these metal in the reactivity series. So you know reactivity series, but once more I would like you to revise it. Reactive metals can displace the less reactive metals from their compounds, and this is the basis for the reactivity series. It is just the list of metals which are arranged in order of decreasing reactivity. Means the metal which is at the top is most reactive as compared to the metal which are lying below. The reactivity decreases from top to bottom. Now next topic is how do metals and non-metals react with each other. So before discussing that, I would like you to see these elements and their atomic number and electronic configuration. If we talk about noble gases, you can see helium, neon and argon. They are having 2, 8 and 288 configurations respectively. Means their duplex and octet are complete according to the Bohr-Bury scheme which you have studied in class 9. They are completing their octet and duplex. Okay. Now if we go on metals like sodium, it has an atomic number 11, configuration 281, magnesium 12, 282. Similarly, aluminium, potassium and calcium. So here what you observe that metals have 1, 2 or 3 electrons in their last shell, and you know that electrons in their last shell are known as valence electron. Same way, if we talk about non-metals like nitrogen, it has 5 electrons in the L shell, that is its valence shell. Oxygen 6, chlorine 7, sulfur again 6. So we can infer this that metals are having 1, 2 and 3 electrons in their valence shell, and non-metals are generally having 5, 6 and 7 electron in their valence shell. So metals, if they give their electrons, they can become stable. It has 1 electron. If it gives that, then it will complete its octet and it will become stable. Same way, non-metals, if we talk about chlorine, chlorine has 7 valence electron. If it receives 1 electron, it will again able to complete its octet. Same way, it is same for all the non-metals. So metals donate their electrons. While donating, they become positive ion, that is cation, and non-metals, they receive electron and they become anion, that are negatively charged ions. So first let's discuss these things, then we will move on to the reactions. Metals, as you all know, they have enough electrons in their valence shell, and non-metals are having deficiency. So they both undergo into an agreement or pact where metals are losing electrons and non-metals are accepting. By losing, metals change into positive ion, that is cation, and non-metals into anion. Now these oppositely charged ion, they are held together by a force ionic electrovalent bond. It is actually the electrostatic force of attraction which is holding the oppositely charged ions. Okay, that is known as ionic or electrovalent bond. You should not take part in the bond formation. Only the valence electrons are formation of valence. Force of attraction, ionic bond. So the compounds which have these kinds of bonds, they are said to be ionic compounds. So whenever a metal and non-metal react together, they form ionic compounds. Let's study more about them. Metals, as you all know, they lose electron, therefore they are called electropositive element. Let's see it by an example. For example, sodium, it has an atomic number of 11. Electronic configuration will be 281. If it gives 1 electron, the electronic configuration will turn to 28. Na plus, it will become more stable. Same way, magnesium 12282. If it gives 2 electron, then it will become more stable and the configuration will become 28. Similarly, for non-metals, chlorine 17, it is 287. If it gains 1 electron, the configuration will turn to 288, more stable. And oxygen, if it gains 2 electron, again it will become more stable. The configuration will be 28. Okay. So let us see some more examples for formation of ionic compounds. For example, this first example I have taken from your book only. Sodium, you know, 281, it will lose 1 electron to become 28. That is, its electronic configuration will be stable. Same way, chlorine will accept 1 electron to form 288 configuration. This can also be represented Lewis symbols. Okay, so Lewis symbols consist of just the dots and the crosses in the valence shell. They can be represented and ionic compound formation can be shown. So here sodium is having 1 electron in the valence shell. Here you can see it is placed like this. Chlorine is having 7 electrons in the valence shell. So 1 electron can be donated to chlorine. So sodium has donated 1 electron, so it will gain plus 1 charge here, and chlorine, it is accepting 1 electron. So it will have one negative charge here. Okay, so this is the actual representation of formation of ionic compounds using Lewis symbols. Let's see some more examples. Try to do this by your own also. Magnesium, it has 2 valence electron, chlorine again 7. So 2 valence electron will be donated to 2 chlorine atoms. Now the formula will be Mg plus 2 here because it has donated 2 electrons, and Cl whole bracket twice because 2 chlorine atoms have received these electrons. Try to do for NaO also and MgO. Oxygen 286, 6 electron. So 2 Na ions will be given 1 electron here. So it will become Na2O. Same way for magnesium. Magnesium has 2 electrons in the valence shell. Both the electrons will be donated to oxygen and it will become MgO. I hope this concept of ionic compounds and ionic bonds are clear to you. Try to write a few more compounds by your own. Thank you so much.